Okay, got my circuit built, and I haven't um, hooked it up to any AC signals yet, but it works. Yay, it works! What I'm doing is I'm running the circuit on this 9-volt battery, which it doesn't use a lot of current, it's very small current, and I've got my meter hooked up to the output, which basically goes to the MOSFET driver, the actual MOSFET driver, which is probably the next stage. I've just got resistors stuck across there so I can clip my leads on. As I put these little sockets on here so I can just plug wire straight in. First of all, is my audio working? Because the other day I made a video and the flipping audio was muted. Oh, it looks like my audio is working anyway. Anyway, this is a bit awkward to do with one hand because, right, so there's my meter. That will register the output when I trigger it. Now, I've actually got my leads back to front, so I need to put these right way around. But just a minute. Oops, damn it, falling off. Get my leads on here. I'm trying to get my leads on here. Well, it's strange because they wanted to go on the wrong way around. Oh, what's happened to me thing? Come on. Right, get on. Right, where's my red one? I'm trying not to pull the board and everything on the floor because this is what's going to happen if I'm not careful. Ah! You bugger! Hang on. I'm trying to do this with one hand and this flipping thing is stuck again. What the hell? It's stuck on me. This thing keeps going. There we go. It's working. It was working. Stupid thing keeps getting stuck. Right, let me just bend that resistor over a bit so things don't fly off as easy. Right, hook it on there. Hook that on there. Right, stay. Don't fall off. Okay, so what I'm doing, I've got these leads connected to this battery, which is totally flat. Well, it's really, really flat. It's about, yeah, about 3-4 volts. It's supposed to be 9. I'm using a flat battery for safety and it's low current, so I can test this without risking blowing any transistors, you see. My meter is, I'm going to try and get my meter in as well. Let's just move this battery over here. I can move my meter a bit closer. Now, when I trigger the circuit, it latches on, which is what it's supposed to do. But the way it works, where it's supposed to work, is that there's two coils. The trigger coil on the on state triggers this, and it's normally AC. So normally this signal comes in, it's supposed to be alternating AC, so it's supposed to be basically plus on the left, plus negative on the right, then plus on the right, negative on the left, and so forth. So I've got to simulate that. Now if I trigger it now, like this, my meter, look, it shows an output on the leads. So I've got 7.61. Now, because of the circuit I built into it to prevent it from latching and staying latched for too long, you'll notice that after a few seconds, it will disengage by itself, which is what it's supposed to do. Right, so we'll just wait for that to time out. You'll notice that it will actually go out at a certain point, all by itself. It's a bit longer than I expected, but that's no problem. I mean, it simply means putting a smaller capacitor in there if I want. But it's, look, it's about to cut off now by itself. It's at 7.59 volts output per. It'll be going through a biasing resistor on the MOSFET anyway, but it's on the verge of cutting out. Come on. Yeah, it is a bit longer than I wanted, but it works. That's the main thing. It works. It does do what I wanted it to do. I need to adjust my timing slightly on the latch state. The latch state is simply prevent overloading or driving a coil when the generator is not moving. We don't want to be sending a static pulse, a static signal, static drive to the coil constantly when we want the circuit to be basically disengaged. Look, it's about to drop off in a minute now. 7.58. It's actually dropping off as the gain of the transistor starts to subside. and it will basically just go off at a certain point. Yeah, so basically while we're waiting for that to happen, if you look at my circuit diagram, we're going to try and keep the meter in, but basically we've got C1, which is 4.7 microfarad, which is just above my thumb right there, and that wants to be changed to a 1 microfarad. And my meter is still, yeah, it hasn't quite gone off yet, but for some reason when I touch the board with my hands, it goes off straight away. I don't know what's going on now. Let's check there's nothing in warm. No. Anyway, so, and no, anyway, oh, it's gonna go any minute. Look, it's twitching. It's twitching. It's dropped to 4.57. It's just it's the way the transistors work. They're in a locked state at the moment. But that capacitor, that electrolytic I was just showing you in the diagram, it might be a bit leaky actually. There is a 1 meg resistor across it as well to discharge it. So it might be that it's just getting enough from that 1 meg resistor to keep it latched on. But anyway, no worries. At least it works. Now, let's just show you how to turn it off. To turn it off, I just touch the off signal, the off trigger, which is this other resistor on this end. Well, this other socket on this end triggers it off. If I touch that now, you'll see it goes off. Look, now it's off. Now, we want to trigger it on again because that capacitor will be charged up. Now look, it won't turn on again. Oh yes, it did. Actually it did. Oh well. Now let's turn it off. It works. Turn it on. Now it won't turn on, look, because that capacitor is charged up, and it's supposed to be AC. So we reverse the connections, simulate AC. So we bias the capacitor the other way. Go back to that one, and now it will trigger. Go back as AC because it's alternating, remember, coming in. We discharge the capacitor the other way, put that back over there, and we can turn it off over there. Trigger it again. Go back over here. Simulating AC by alternating the wiring. And this won't trigger it off, because it's the opposite polarity. It has to be a positive pulse in this end. These two at this end are actually ground, so when I put this onto here, I don't have to put it onto there because these are both ground. Well, both connected together, both common connections. So it's gone off again. Right, let's trigger it. It's triggered. Trigger. Turn it off. Turns off. So we got a trigger on and a trigger off, which is exactly what I wanted for my timing on the generator system. Let's just reverse polarize it, otherwise that capacitor charges up. Oh, my wire fell off. Ah, my clip fell off. Come here. Flipping thing. Right, oops. If I can get it to stay on. This is being awkward with me. Right, stay. Right, got that on. Right, the meter. Now let's go back to the meter. Right, trigger on. Oh, it won't trigger now, look, because the capacitor is charged. Oh, see the blue LED flicker then? You see it? Right, anyway, let's reverse polarize it. Right. Now watch the blue LED when it receives the pulse. Are you watching? There you go, you saw it pulse. That's the pulse LED. If you read what it says on the board, pulse LED. And the disable SS off, which is down there, the green one. You can't see it properly, but it says SS off. That's soft starter off. Now the soft starter off basically disables the soft starter once it gets enough voltage to drive the main circuit, which it's obviously doing, because otherwise it wouldn't be latching at all. Right, so let's just see if my soft starter LED flickers at all. Oh, actually I need to reverse the polarity again. it would help if I turn the lights out, because you can't really see very well. And notice I've got 10 mega resistor in there. It's just to hold clip onto, really. What I need to do is turn off the big light, because you can't see very much. You can't see the LEDs very well. So right, I've turned off. The focus is all weird now. Right, so let's see if this. I don't know if the soft starter LED is going to work, but it's daylight outside as well. But let's just see. No, it didn't actually light up, but it would do if it was constantly getting a pulse. I'll tell you why it's not working. And it's good. It's a good thing it's not coming on, really, because look at my circuit diagram now. The soft starter LED is L2, is LED 2, right? Now that only comes on, right, when this capacitor is receiving a sufficient voltage through here. So basically we have to have this is the LED that's triggering the circuit. Now this pulse comes through the opto-isolator, triggers the circuit on, the latching circuit down here, right, triggers that on, and when that's pulsing constantly, what happens is we have a tap here, which some of the power comes off, goes through the green LED, and it starts through that resistor, which is a 4.7K, and it turns off the this MOSFET, which basically disables the soft starter, and this capacitor has to charge up to keep it in an off state. If the green LED is not lighting up, then it might be I need to drop this value of this resistor a little bit. I might have to stick a 1K in there, or 470 ohm or something. But at least the circuit generally is working, because that's basically what I'm seeing happening. Just not seeing the green LED come on yet for some reason. It might be because my voltage is too low. That's probably what it is. So what I'm going to do now is I'm going to get a bigger voltage. I'm going to send a much bigger voltage. So instead of a flat battery, which has only got 3 volts in it, we really need to simulate a voltage of something like 12 volts. So what I'm going to do is I'm going to get my this 12 volt let's see, actually I don't even need 12 volts. Let's just use these two. There should be about 6-7 volts in these lithium ion batteries, but I'm not worried about current because it's already going through biasing resistor. So let's just connect these onto these batteries, and then I should have a little bit more voltage, and we should be able to see the disable circuit act up, or trigger. Now let's try it again. Now let's see if we see the green one light up. I'll have to reverse it a minute first. Right, just reverse. Right, now let's go the other way around. We should see the green LED. Oh, still no green LED, but at least we've got the blue one flickering. The blue one came on. So it's not latched at the moment. Discharge. Well, AC. I'm just basically discharging the capacitors in series with the AC part. So that's triggered. Let me just go to off and on. Oh, that's interesting. It's not triggering now. Why is that? It's not latching now, I mean. Oh, it did come on. I see what happened. It's working through the pulse, so that capacitor has to charge up sufficiently. That's, oops, flipping leads falling off again. So that capacitor has to charge up sufficiently to disable. That's why the green one hasn't come on. I need to get some new. These leads aren't clipping on very well. Right. I need to do this faster, and I can't do it faster because I'm holding the phone. Oh, actually, I can do it faster if I get my signal generator on it. Yep, that's what I'll do. What I'll do is I'll get my signal generator hooked up. And I'll start feeding AC signals into it. That's probably the one I need to do. Right, so I don't know if I can do that while I'm live at the moment, because I don't know how long it's going to take me to do that. Let me just see. Actually, it won't take me long. I need these batteries. I need these batteries to connect it and plug into my signal generator to run it. So I'll just plug these in. Where's the right socket? There it is. Right, the signal generator comes out. Where's the wire gone? Signal generator wire. Where are you? Here you are. Right. Right, I'll just move these batteries out of the way. I should be able to produce a good high signal with this. Or if it's long enough. If the wire's long enough. Okay. Oh, God, this is just going to reach. Only just going to reach. Right. This needs to. My leads are coming off again. Sorry, I'm trying to get this on here. Right, I've got it on the input. That's the trigger on side. And my clips come off again. Come on, you bloody. This lead's gone. The lead's gone funky on me. I need to get a new clip, I think. Oh, there we go. What's wrong with it? I don't want to mute myself by accident like I usually do. Right, this is the output side. Let me just check, make sure my audio is working. It looks like it is. Right, let's turn on my signal generator. Oh, look what we got. It's turned on. And that's working. Let's turn up the gain. Gain to maximum. Well, at maximum now. Is that green LED going to come on? Can't see it. Oh, look. Oh, no. Sorry. I saw a light somewhere else. Right, the green LED is not coming on, so I'll have to sort that out. There's a little problem with my disable circuit. And mind you, it might be because that capacitor is too big. Because the green LED, let's have a look a minute at my circuit. It's staying on anyway, it's latched state at the moment. The disable circuit is supposed to kick in, which is U4 there. And we've got a 4.7K R10. And the LED 2 is the green LED, and that's basically tapping a signal off, and that goes through the BC 109, and that's actually that BC 109. Let's see if that. Oh, that green LED. I wonder if I've got the green LED in the wrong way around. That could be what it is. Shouldn't have done that. Should be in the right way around. Anyway, it's staying on right now, but that's okay, because if I feed that signal to the off state, it will go off. So let's just try that. Oh, it's actually gone off straight away. It shouldn't have done that. Oh, actually, it's but the thing has charged up. I think what's happened was that I've got a problem with leakage on that capacitor, and it's clearly not charged up enough. And as soon as I sent a pulse, it was able to disable. So let's just send a signal to the off. Now it should. Oh, it's not coming on. Oh, actually, I've just realised my signal output, my signal is on the positive lead here, goes high. It's not a proper AC signal, it actually goes high. So let's reverse this. That's the problem. It's not proper AC, it's actually pushing it high. I saw it twitch then. Let's move it back again. Yeah, it just flickered then. Oh, the other thing is in my trim pots want adjusting. Yeah, so let's just adjust my trim pots because the voltage on these isn't that great. So I'm just going to, actually, which way around do I want to turn this? I don't know. Let's turn it anti-clock. Oh, I saw the blue LED flicker then. Right, let's just trigger it again. Let's reverse it. Let's go to ground. I was to turn it down. Right, so it's hard to coordinate my hands, and I'll turn it about 3/4 up. Oh, my leads come off. That's what it is. My flipping leads come off again. This end. Stay on. Right, let's try again. I can't get everything on all at once. Oh, look, it's triggered. Look, it has come on. And then off. Yeah, it works. It does work. I just had to turn the gain up on my trimmer pot a bit. On. Yeah, it's working. It's working, yeah. Off. Yeah. On. Well, I am getting DC bias from my oh, this lead's come off again. Yeah. I think it's going to be best when I get some coils hooked up to it, because it's supposed to run off coils, and the coils are basically proper AC, and they'll get a positive cycle and a positive negative cycle on them, but I'm not getting that for this because there's leakage on the signal generator is producing a signal generated, and there's a slight bit of biasing on the positive side, so it's higher on the positive side than it is on the negative side. That's why I'm having problems with it. Yeah. That's obviously the problem. Let's clip on there and we'll find out. You see, it's not working the other way around, look. It's not triggering the other way around, so I am getting positive biasing for the... If it was proper AC, it should actually work either way around. Yeah, that's what's happening. I've got leakage. The only way to stop that would be for me to put ceramic disc capacitor on across on the end of one of the leads, but yeah, there's no point really. At least I can see that this thing works. My flat battery, I'll just try and turn this off again with my flat battery if I can. There, it worked. Flat battery turned it off. Let's turn. I'm just using this flat battery across this resistor. Right, anyway, just a little update on the circuit board that I've just built. I need to get fiddling around with that green LED section and figure that out, because there's just one problem with the soft start killer thingamajig, and so it's LED 2 that's not coming on, and I think actually I have an idea what the problem is. I've just realised something. The amount of energy that's required to turn on U4 is extremely small. It's so small, in fact, we're talking about possibly less than a milliamp. It's disabling. U4 is being triggered, but there's not enough power flowing through here to actually drive this LED. That's what it is. So U4 is being disabled. It's being triggered, but it's been triggered with such a small amount of current. There's not enough current to actually operate LED 2. So how do I solve that? Basically, I don't think I do. I think I just have to basically take out LED 2. Or actually just use LED 2 as a voltage drop, because it balances it. Yeah. So LED 2 is not going to really work, because this device, if you go and look at the data sheet on it, it's a DN25440N3-0. So actually that isn't going to conduct. There's not going to be enough current on the gate to actually make that LED come on. A bit of an oversight. Oh well. The only other way around that would be to have a bypass diode. Actually, that would work. I could have a bypass diode, an extra diode. Actually, I put an extra resistor on the circuit earlier, because I thought that, well, I didn't include it on the circuit board. I thought that this capacitor C7 needed a bit more ground, but it doesn't really, because this BC109 is going to be pulsing all the time. So actually the resistors are cross BC109, so that's no good. Let me think. No, because if I put a resistor across there, then it's going to basically turn on the output section prematurely, so that's not going to work. This LED 2 basically it's kind of not serving any purpose really. But anyway, I'll have to leave it, because I want the voltage drop across it. There's a voltage drop across the LED, obviously, and I'm using that voltage drop. I could take it out and put a Zener diode instead, so yeah, I might do that. I might just stick a Zener diode in there, take the LED out, stick a Zener in, because... Oh, my phone, hang on, I'll have to go. Bye for now. Oh, shit. Hello?
Oh, hello, is that Michelle there?
Yeah, speaking.
Hi, Michelle, I'm just calling from Brook Square Surgery.
Oh, just give us a second, a minute. I'm trying to kill this live stream thing, and I don't want to talk on live stream.
Oh, right, okay.
Hang on a minute. Hang on, I'm trying to kill